completing this module, you will be able to apply the procedure of triangulation to estimate the extent of land, describe the methods of computing the chain angles. Let's observe the step-by-step description to measure the area of the given field by chain triangulation. As a first step, gather these instruments: a chain of 20 or 30 meters, arrows as required, ranging rods as required, and pegs as required. Identify the field whose area is to be measured. Now, establish the survey stations. As you know, the survey station is a prominent point on either at the beginning or the end of the chain line. Look, in this field, A, B, C, D, and E are the main survey stations. You know that any line joining the main survey stations is called a main survey line. The biggest of the main survey line is called the baseline. Mark the baseline as it helps you to take command of the field. That is, it acts as a reference line. Mark this baseline with chalk powder. You know that any line joining the main survey stations is called a main survey line. The biggest of the main survey line is called the baseline. Mark the baseline as it helps you to take command of the field. That is, it acts as a reference line. Mark this baseline with chalk powder. Divide the area into triangles. Note that with the baseline, one triangle EDC is already formed. Using the chain, if you join the points A and C, you will get two more connected triangles, CAE and CAB. Look, this framework now gives three connected triangles. One is A1 connecting EDC, the second is A2 connecting CAE, and the third is A3 connecting CAB. Once you have the area of each triangle, you have to sum up the areas of all triangles. Here we have areas of three triangles, A1, A2, and A3. When we sum up the area of these three triangles, A1, A2, and A3, we get the area of the given field, that is, ABCDE, as equal to 217.95 square meters. Assume that there is a pond in this field. Using a chain, you cannot form triangles in this field with a pond. In such a case, the angles between adjacent sides are fixed by chain angles, either by tie stations or a cord. Let's understand the formulation of any one chain angle for the field ABCDE using the tie stations. On the main survey line AB, fix the tie station T1 at some distance, say 3 meters from A. Now, hold the handle at the main survey station A and fix another tie station T2 on the opposite main survey line AE, but at the same distance as above. In this case, it is 3 meters. Use a tape or chain to measure the distance between T1 and T2. Measure the distance between T1 and T2. Now, the principle of chain survey or chain triangulation is to provide a skeleton or framework consisting of a number of connected triangles. The steps for estimating the extent of land using chain triangulation are: Step 1. Gather the instruments. Step 2. Establish the survey stations. Step 3. Establish the baseline. Step 4. Divide the area into triangles. Step 5. Measure the length of all lines. Step 6. Calculate the area of each triangle. Step 7. Calculate the sum of the areas of all the triangles. The two methods of computing the chain angles are by using tie stations and chord. You have seen that surveying is a method of showing the relative positions of objects on the ground. Do you know, by showing the relative positions by means of offsets and oblique lines, you can locate ground features? Let's find out how we can locate ground features by going through this module. Locating ground features. Welcome. After completing this module, you will be able to identify the types of offsets, state the use of different survey lines and running perpendicular lines to a survey line from a point, and an offset is basically a distance measured from a survey line to a certain point or object located on one side of the line. Offsets are taken to know the distance between a survey line and a point or an object. For example, on this plan, let us take a look at how we can know the distance from the baseline to each of the points A and B. As there are no obstacles between the baseline and A, you simply need to run a line from the baseline to the point A. So that it is perpendicular to the baseline. This perpendicular line is called the perpendicular offset. But what about an offset to connect B with the baseline? As you can see, there are obstacles between the baseline and B, making it difficult for a perpendicular offset to be taken between the baseline and B. So, you must take an offset from the baseline at a point which is closest to B, although not perpendicular to it. Such an offset is called oblique offset. So, remember, the two types of offsets are perpendicular offset and oblique offset. The perpendicular offset is taken when there are no obstacles in between from the baseline, and the oblique offset is taken where there are obstacles in between. When taking offsets, the survey lines we must mark on the ground are the baseline and the check lines, or the lines running to the offsets. As the baseline runs across the central region of the area, identify and mark it correctly on the ground so that you can run the check lines or the offsets from it. Once you have taken the perpendicular offset and measured it with a tape, you can show it on the survey plan as a check line. In order to take an oblique offset from the baseline, identify the point on the baseline that is the closest to the oblique offset point, without any obstacles in between. Once you have measured the oblique offset, you can show it on the survey plan as a check line. So, remember, the baseline and the check lines are the important survey lines while taking offsets. You can use the cross staff to take the perpendicular offset and the chain to take the oblique offset. We've had a look at the types of offsets. Now, let us find out how to locate ground features using the chain or tape and offsets. Suppose you have the plan of an area and have to locate a feature on the ground marked by it, such as this pit. By running offsets at the opposite ends of the pit, points A and B, you can locate the pit on the ground and check whether its position is correctly shown on the map. The perpendicular offset to A can be taken at A by setting a cross staff at the baseline directly opposite it, and then running a chain or tape to it. And an oblique offset can be taken at B by running a chain or tape from B to the point on the baseline nearest to it. By comparing the lengths of these offsets with those on the plan, we can check whether the position of the pond is correctly shown on the plan. So, remember, by running offsets on the ground with the help of cross staff and chain or tape, you can locate ground features and check their position on plans. In this module, you have learnt how to identify the types of offsets, the use of different survey lines, and running perpendicular lines to a survey line from a point, and to locate ground features using the chain and offsets. The two types of offsets are perpendicular offsets and oblique offsets. The cross staff is used for running perpendicular offset. The chain is used for running oblique offset. When taking offsets, the survey lines we must mark on the ground are the baseline and the check lines. We can use the cross staff and the chain to run offsets so that we can locate ground features. The first of these methods is the average offset method. With this method, you can compute the areas of regions with irregular boundaries made of straight lines by taking perpendicular offsets. First, run a long line from one end of the area to the other. Then, divide the line into equal chainages or distances. Measure the equal distances with a chain or tape and mark equal lengths by driving arrows into the ground. To the extent possible, try and keep the chainages equal. Then, take the perpendicular offsets by placing the cross staff at equal chainages. The distances you obtain in this way are called ordinates. Ensure that you take the offsets in such a way that the end of one ordinate is joined to the other by a straight line of the irregular boundary. Once you have the required number of offsets in the area, you can calculate the area with the formula. To follow the mid-ordinate method, you must draw ordinates at each of the points of division of the baseline. To obtain the required area, multiply the average of these ordinates with the length of the baseline. For example, the trapezoidal rule is applied in the case of areas where each part is assumed to be a trapezoid. The trapezoidal rule can be stated as follows. To the sum of first and last ordinates, add twice the sum of intermediate points. Multiply the total sum thus obtained by the common distance between the ordinates. 1/2 of this product gives the required area. Simpson's rule is applied in areas where the boundary lines are like curves and arcs. The rule can be stated as follows. To the sum of the first and last ordinates, add 4 times the sum of the even ordinates and 2 times the sum of the odd ordinates. This sum, multiplied with 1/3 of the common interval between the ordinates, gives the area. As the results obtained by using Simpson's rule are more accurate, it is used when greater accuracy is required. If trapezoidal and Simpson's rule are to be applied, then note that the interval between successive ordinates must be uniform throughout the length of the baseline. If the interval is not the same, divide the baseline into different sections, each having the same interval. Calculate the areas of each section separately and add them up to get the required. In this module, you have learnt the steps involved in field data entry and cross-staff survey for estimation of areas, and also to find the area by using chain and offsets. In the average offset method, the area is computed by dividing the baseline into equal chainages and taking perpendicular offsets by placing the cross-staff at equal chainages. In the mid-ordinate method, ordinates drawn at each point of division of the baseline are used to compute the area. In the trapezoidal rule, this formula is applied to compute the area. Similarly, this is the formula to be used for computation of area by the Simpson's rule.
To know the extent of land with a cross-staff, you must first establish the base line of the area. To mark the baseline, run the chain over the center of the area, connecting the 2 main stations that are the farthest apart. Then, set the cross-staff at a point on the baseline so that you can sight 2 main stations, one at the end of the baseline and another that is the closest to it. If needed, adjust the position of the staff on the baseline so that your line of sighting to one station is exactly perpendicular to the other. Mark the point on the baseline and measure the length from it to the survey station. As you know, this position is called the offset. In the same way, move down the baseline and mark the other points on it that connect it to the other offsets and take the respective measurements. By drawing lines from the baseline to the offsets, you can divide the areas into triangles and quadrilaterals. You can now find out the total area of the land by adding up the areas of all these shapes. So, let us find out how to calculate the areas of the shapes. We can calculate the areas of the paths into which the site has been divided by using standard mathematical formulas. Let us find out what they are. If some of the paths are divided into right-angled triangles, their area can be calculated with the formula area is equal to half base into height. The formula for calculating the area of the paths in the shape of a trapezium can be given by the formula half the sum of A and B into H, where A and B are the parallel sides and H is the vertical line joining them. With the help of these formulas, we can calculate the areas of the paths of the site and add them up to obtain the entire area. In this module, you have learned how to use cross-staff survey for finding the extent of land. To find the extent of land with cross-staff survey, you must carry out a number of steps, such as marking all survey stations, running a chain along the baseline, setting the cross-staff along the baseline, taking offset measurements, dividing the area into parts. The whole of the area can be computed by summing up the areas of all the parts.
You know that chaining is a standard technique used in surveying to measure distances between objects so that their relative positions can be shown accurately on a map or plan. Sometimes, surveyors encounter some basic problems when they are trying to obtain points of reference at places other than the chain line. So, what are these basic problems in chaining? How can we solve them? Let's find out the answer to these questions in this module, Basic Problems in Chaining. After completing this module, you will be able to apply the procedure for erecting a perpendicular from a point on a chain line, dropping a perpendicular from a point to a chain, and running a... The first of the basic problems in chaining is erecting a perpendicular from a point on the chain line. The perpendicular can be erected by a method called the 3-4-5 method. Let us find out what this method is. In this method, a measuring tape is shaped into a right-angled triangle so that the triangle's base begins at the given point on the chain line and the triangle's top is perpendicular to the given point. Let's see how this can be done. First, mark the point on the chain line at which the perpendicular is to be erected with an arrow. Let this point be B. Mark another point C on the chain line such that B is 3 feet or 36 inches from C. Keeping the 3 feet mark held at B, roll out the tape vertically above B up to the 7 feet or 84 inches mark. Let's say this is point A. With A held straight above B, extend the tape back to C. You'll see that the reading at the extended end of the tape at C is 12 feet or 144 inches. As you can see, you have formed a right-angled triangle ABC with the tape. As a result, any point on AB will be perpendicular to BC at B. This method is called the 3-4-5 method because a tape length of 12 feet is shaped into a right-angled triangle having sides measuring 3, 4, and 5 feet. So, remember, to erect a perpendicular point from a point on the chain line, follow the 3-4-5 method. The second basic problem in chaining is dropping a perpendicular from a point to a chain line. Here, let's say AB is the chain line and C is the point from which the perpendicular is to be dropped. Mark any point on the chain line with an arrow. Let this point be D. Take a line dory that is equal to the length of CD. Then, holding that length of the dory, mark another point E on the other side of C on the chain line such that CD is equal to CE. Measure the length of DE along the chain line. Mark the midpoint of this length. Let this point be F. The line CF will be perpendicular to the chain line AB, as the lines CD and CE are equal sides of the isosceles triangle CDE. So, remember, to drop a perpendicular from a point to the chain, mark equal lengths of line dory on either sides of the point on the chain line. The line from the point to the midpoint of these two marks will be perpendicular to the chain line.
अरे गीता, तुम मेरे घर आई ये तो बहुत अच्छी बात है। वास्तव में मुझे इंटरनेट के बारे में कई महत्वपूर्ण बातों को समझने में तुम्हारी मदद की जरूरत है।
जरूर चाचा, मैं यहाँ आपकी मदद और मार्गदर्शन के लिए आई हूँ।
देखो गीता, जब मुझे ट्रेन से कहीं जाना होता है तो मुझे बहुत